Okay, let's do a couple examples together. Okay, so first off, this example is so similar to the one that we just did. So let's move on to our next one. Okay, so we're going to add a vector whose magnitude is 13 meters and an angle of a positive 27 degrees from the x-axis to one whose magnitude is 11 meters and the angle is plus 45 degrees from the x-axis. Okay, let's draw this. Let's see what we have. So we're going to have 13 meters at an angle of plus 27. Well, 45 is like right in the middle of that, and so we're going to be below that. We're going to be at 13, so it's going to be something like somewhere in that range. Okay, so this has a magnitude of 13 meters and it has an angle of 27. And see how it is a positive 27 from the x-axis? Like if we're calling this 0 and we go up 27 degrees, that's where we get to our angle there. Okay, and now we have another one that's a magnitude of 11 at 45 degrees. Okay, so 45 is kind of like right in the middle here. So we're gonna be something like that. Okay, so we're gonna have 11 meters is my magnitude, and then this big angle all the way through, that's 45 degrees. Okay, so we're going to add those vectors, and let's see what our resultant vector is, and let's even calculate the angle of that resultant vector. Okay, so first, this 13 meter vector, let's find the x and y component of that. So when I look at this triangle here, the x component is adjacent and the y component is opposite. So 13 meters, and let's name these because that'll just be helpful. Like let's call this one vector A and vector B. Okay, so 13 meters, and we're x first, so cosine 27 is going to equal a sub x. Okay, and a sub x, so 13 cosine 27 11.5831. Okay, and then we have units of meters. And then 13 meters sine 27 would be a sub y. And that is 5.9018 meters. Okay, and now let's find b sub x and b sub y. So our magnitude of 11 meters, and then again our adjacent for b is the x. So we're going to have cosine, the angle is 45, okay, and that's going to equal b sub x. So 11 times by the cosine 45, so that's 7.77817, and then we're going to do 11 meters sine 45, should be b sub y, and we should expect the same number because cosine of 45 and sine of 45 are the same. Okay, at this point I like to hit pause and decide, are these positive or negative values? So a sub x is positive, a sub y is positive. b sub x is positive, b sub y is positive. Okay, so all these stay the same. We don't add any negative signs. So should we continue with this trend? We'll call our resultant c. So our c vector is going to equal ax plus bx plus ay plus by, and that's the same thing as cx and cy. Okay, so let's plug it in. AX is 11.5831 plus BX is the 7.77, and then the Y component there, A sub Y is 5.9018. We're going to add that to the Y component B, 7.7787, right? Run those numbers. $19.36113 meters plus 13.6801 meters. Okay. Between 3 to 5 sig figs, here we have 1, 2, 3, 4, 5, 6. So I think I'll drop that 1. Okay. And now let's use Pythagorean theorem to figure out the magnitude of C. Okay, so just a reminder, like our C vector here, we have positive 19 in the x direction, and then we have positive 13 in the y. So probably like somewhere up in this range, right? That would be my resultant vector, somewhere in there, like from the origin out, like that. So you'd have some resultant. I'm going to just draw it really lightly here. Okay, we're going to have some resultant. That's going to be our C value. And so we have C sub x and C sub y. So we're going to use our Pythagorean theorem here, where cx squared plus cy squared equals c squared. Take the square root of both sides so we can get c by itself. So the square root of cx squared plus cy squared will equal c. And I'm going to plug those numbers in. Okay, so I'm going to take the square root of c sub x, which is that 19 number. I'm going to square that, and I'm going to add that to my c sub y. Make sure I square that. And my final answer is 23.71 meters. Okay, so that's the magnitude of our resultant. Now let's solve for the angle. We want to know what this angle is. These are calculated, so let's start with that. Let's use tangent. So we're going to say tan of theta, and theta is going to be this angle that we're solving for, okay? So tan of theta is going to equal, so opposite, which would be c sub y, over adjacent, which would be c sub x. Okay. And so then how do we solve for tangent? We need to use that inverse function. Okay? So tan inverse of cy over cx will tell us theta. Okay? So I'm going to take my cy value, I'm going to divide it by my cx value, and then I'm going to do the tan inverse of that. And when I do that, let's see what we get. So tan inverse of my cy, which is 13, divided by my cx, which is the 19 number, I get an angle of 35.24 degrees. Now ask yourself, is this logical? Well, this is 27 degrees right there. That one's 45 degrees. And so this one is less than 45. And so that's a reasonable number. So it's a good way to check that you did your work right. Okay? Alright, so on our last video, we have 3 more examples. I think I'm just going to pick one more, and we'll just take one more example. So if you're feeling confident, you're like, nah, Mrs. H, I totally got this, then go ahead, move on, start on the assignment. But if you're like, I'm still not sure, then one more video, let's do this one more time, because I know it requires a lot of our math skills, okay? All right, see y'all soon.